Hey guys, we're going to talk about slope today, and slope is a little bit of a review because you would have learned a little bit about this in 8th grade. So let's go over some of the concepts of slope so that we're prepared for class today. So slope describes like the incline of a line or like the angle that the line has on a coordinate grid. So we're talking about its tiltedness, its incline. That's the slope. Sometimes the slope is called the rate of change, but always it is the letter M. So there's a graphic on here called ROCM's, or rate of change, which is your M variable, stands for slope. So ROC stands for rate of change because it's how quickly the graph is changing or how it's tilted. It is the letter M, and again, this is your slope or your slope to help you remember that it's the M. Now there are 4 types of slopes that we can look at. I'm going to draw them in a very particular way. It's going to make like a cool little face. So if I have a slope that looks like this, you would say that this slope is going up or it's increasing. Like I read a book, I read it from the left to the right. So this is increasing. It is a positive slope. If I have this graph or this line, this graph is going downhill or decreasing. That is a negative slope. If I have a straight up and down line, up and down is undefined. So I'm going to put a big U underneath here. Then if I have a flat line, it's like it's got no heartbeat. So if it has a flat line or no heartbeat, that has 0 slope. This kind of looks like a face now. We're going to call this slope guy. Slope guy helps us remember the 4 types of slopes that we have. Positive, which is increasing, negative, which is decreasing, up and down is undefined, flat line is 0 slope, like the little dimples there, 0 slope. One thing I want you to for sure remember that when we're talking about slope, we're talking about just the M. Okay, you're going to be very tempted to say that in the equation y equals 3x plus 7, that the slope is 3x. That's wrong. The slope is just the number in front of the x. So this is just the M or just the 3. Okay, please remember that. I'm going to make a big deal out of it. The slope is M, not including the x. Let's go see some of the ways that we actually calculate or find the slope. One of the ways we're going to be asked to find slope is finding the slope from a graph. Now, when we find the slope from a graph, we're going to count the incline, talking about the rise and the run. When I talk about the rise and run, I'm talking about how much it goes up and down and how much it goes to the right. We're always going to run to the right on our graph to count our slope. It's the positive direction, so it's just easier to count that way. Let's look at the first example here. If we're trying to find that slope, we're trying to find the M, and we know that we need to count the rise over the run. I'm going to do rise in blue. I take 2 of the coordinate points. I'm going to use this one and this one. And I'm just going to count how many it takes to go from the first one to the second one. I jump 2 times, so 2 little boxes, but if I look, that's from 150 to 250. So I went up 100. I rose 100 units. Then if I look at the run, I'm going to do the run in red. I jump over just 1 unit from 1 to 2, so that's by going to the right 1. So my rise is going to be 100 and my run is 1. 100 divided by 1 is 100, and that's my slope for this line, for this function. The rise over the right. Remember, make sure you always count to the right for the run. That's going to make it very easy for you to count this. I want you to pause the video and I want you to try the second one. All right, hopefully you paused the video and you gave it a shot. I need to find 2 coordinate points that I can count. I need them to be nice, pretty coordinate points that go through corner pieces. I'm going to use this one right here and this one down here. Starting with the first one, which is the one on the left, I need to count my rise and my run. To go for the rise, to get to the same level as the second point, I'm going to have to go down 2 units. So I'm going to use a negative to show that I went down. down 2. Then I'm going to go to the right 6 times from 0 to 6 for my run. My slope is negative 2 over 6, and since y'all know I like those fractions, we're going to leave that in fraction form, but we're going to reduce the fraction, and we'd get negative 1/3 as my slope. Negative 2 over 6 reduces to negative 1/3, so my slope is going down 1, right 3. One of the other ways that we're going to ask you to find slope is determining the slope from an equation. We're going to start with slope-intercept form, which is the form that we used when we solved for y. I want you to notice that in slope-intercept form, there is legitimately an m in this formula. And we said that m stands for our slope. This m is right next to the x, always. It is not the x, it is the coefficient of the x, or the big number right next to the x. So when we look at an example problem, I want you to super make sure, again, that you are just using m as the slope. Okay, do not tell me an x. I will legitimately be so sad if you tell me that the x is part of the slope. It is just the coefficient of the x, or just the m. Look at the first example here. It says, what is the slope of the graph of y equals 5x minus 17? The first thing we have to do is make sure that this equation right here is written in slope-intercept form. If it has a y by itself, it does. An mx term, and then a constant for b, we're good. This is in mx plus b format, which means all I need to do is say, all right, the number next to x, which in this case is 5, is my slope. That's it. The slope is 5. You guys try the second one. What is the slope of the graph of y equals negative 1/3 x plus 1? Hopefully, again, you noticed that this equation is written in slope-intercept form. It's got a y by itself, it's got an mx, and it's got a constant b. Okay, we just need the number or the coefficient next to the x, and that's my slope. I'm literally done after just knowing that this is in slope-intercept form. Solve for y, that my slope is negative 1/3. You kind of can't see my negative sign, so I'm going to do it again. Negative 1/3. Now this next one says, what is the slope of the graph of y equals 3 minus x? And you might be saying, Miss Quigley, that does not follow mx plus b. It's not exactly true. The y is still by itself, and I still have an mx term. It just happens to come second, and I still have a constant term. I'm still good. So all I have to do is look at the number or the coefficient of the x, which in this particular case is an invisible number. What's the invisible number that's in front of x? Negative 1. That means that my slope is negative 1, not negative x, negative 1. You guys have the fourth one. What is the slope of the graph of y equals x? Even though that this parent function, which is like most boring version of a linear equation you'll ever see, has no slope showing, we know that there is another sneaky 1 that's sitting right here in front of the x. Mathematicians are just too lazy to write it down, but we know the 1 is there. So our slope is 1. Now this last one is a little bit different. It says, again, what is the slope of the graph of 3x minus 2y equals 18? Hopefully your spidey senses are tingling. You say, that is not solve for y. But guess what? We spent some time last 6 weeks learning about how to solve for y. So we're just going to use those skills. I'm going to move the x term to the other side. I cross the line, I change the sign. Then I just rewrite down the entire equation, making sure that I don't lose any sign or any number. Last thing I'm going to do is divide by the coefficient of the y to each and every term in the equation. I'd end up with y equal to 3/2 x minus 9. Negative 3 divided by negative 2 is 3/2. Please leave it as a fraction. And 18 divided by negative 2 is negative 9. And now that it's in slope-intercept form, y equals mx plus b, all I have to do is identify that number in front of the x, which is 3 over 2, and that's my slope. My slope is 3/2. Now, the only other way today I'm going to ask you to find the slope is by using what's called the slope formula. This formula is useful when you have a table or a set of ordered pairs. This formula is found on the formula sheet that we will use for this class when we take the DCP or the STAR. So it's going to be given to you. You need to know how to use it. This formula says the slope is equal to the difference in the y's divided by the difference in the x's. And it looks really complicated, but what's going to be nice is that if we start off each of these questions by labeling our points, we're going to know exactly where to put these coordinates from the coordinate points or the table into this formula. Okay, this one does require some calculations. So I have Desmos, where's my mouse? I have Desmos sitting here ready to do some calculations for me. I've typed in the equation again here so you can see it, but we're going to be doing the calculations on the next line here. Okay, let's see the first one. We want to label our coordinates. We have x1 and y1. We label them because x comma y is how we write coordinate pairs, and this is just the first coordinate pair. So x1, y1. We label the second one x2, y2 because they're the second pair of coordinates. Then all I have to do is fill them into the formula. This is going to be m equal to big division sign. Let's start filling it in. We need y2 minus y1. Do you see how I've taken the number that I labeled y2 and put it where y2 goes? Then I put a subtraction sign because that's in the formula. Then I took the number that's labeled y1 and I put it behind. If the double negative bothers you, it bothers me. You can put the second the second number in parentheses. Then we continue the formula. The formula says the first number on the bottom is x2, we labeled that one 0, minus x1. Again, I'm taking the number that I labeled x2, plugging it in, and the number that I labeled x1 and plugging it in. At this point, I need to calculate or plug and chug some answers here. You can do this in your head. You can do this with a calculator. I'm going to show you how to use Desmos. So in Desmos, I can go ahead and type the entire equation, how I have it written on my paper, m equal to big division sign. So I'm going to use the button that's underneath or that's connected to the question mark. It's like a slash. Makes a giant division sign. 4 minus negative 7. Again, if it bothers you to have the double negatives, you can put this in parentheses. You don't have to, but you can. I'll show you, you don't have to. Then I have in the bottom, I just went down to get to the bottom, 0 minus 1. And it's going to tell me that my slope, or my m, is negative 11. Thanks, Desmos. Thanks for calculating that for me, which means I know that this slope is negative 11. That's the slope of the line that passes between the 2 points. Pause the video right now. I want you to try the second one. I've already plugged in my numbers to my formula following the formula that's on this page. I just need to calculate. So I go back to Desmos. I'm going to scoot it over so we can read this. And we are going to calculate a big division sign for m. So I just press the divide button. And I'm going to have 15 minus negative 7. Again, if it bothers you that it's minus a negative, you can put the second term in parentheses. Otherwise, Desmos understands. Then I have negative 8 minus negative 2. It's going to calculate and give me an ugly decimal. And y'all know in the back of your heads, you can hear me saying, please give it to me as a fraction, which means I'm going to press the fraction button right here. Box over box changes my answer to a fraction. Oh, that's much prettier. Which means that I know that my slope is negative 11 over 3. Which means if I were graphing this or reading it off a graph, I'd have a rise of going down 11, and I'd have a run of going right 3. That's the slope that passes through the 2 points. Now this concept stays the same when we're dealing with tables because tables are just another way to organize coordinate pairs. So literally nothing is different. For the savings account example, I'm still going to label x1, y1, and x2, y2 so that I can plug them into the formula. The formula is m equal to y2 minus y1. Let me go back. I'll color code this for you guys. Okay, we are going to have y2 minus y1 all over x2 minus x1. Then we start calculating. This one's easy enough to do in our head, so we'll just do it in our head. 39 minus 32 is 7. 1 minus 0, that's 1. And 7 divided by 1 is 7. So if my slope here, or my rate of change, is 7, that means my balance in my savings account is changing by a positive $7 every week. I'm saving $7 and putting it in my bank account every week. It's a rate of change for this savings account. Let's check out this next table together. So again, we label x1, y1, and x2, y2. It's just the first and the second x's and y's in my table. We fill in our formula. The slope is y2 minus y1 over x2 minus x1. Oh, that's wrong. I typed the wrong thing for a second. Minus x1. Okay, we're going to use Desmos for this one because it looks a little funky. So here we go. Let's pop over to Desmos and have this calculate for us. We're going to get rid of this, delete, and we're going to press the big divide. We have -1 minus -2 over 3 minus 3. Whoa, Desmos is telling me undefined. At the beginning of this lesson, we talked about the 4 types of slopes, and we said one of them is undefined. What type of slope is this? Will it be positive? Will it be inclined up, increasing, inclined down, flat, or straight up and down? Yeah, up and down is undefined, so this should be a straight up and down line. So I will legitimately say that my slope here is undefined. For those of you who calculated this by hand, you would be dividing by 0, which you're not allowed to do. It's not a thing. It's an undefined number. Last table on here is yours. Will you please calculate the slope for me for this particular table? So hopefully you labeled your table and you filled in your equation just like I did. When you start to calculate this one, and this one's pretty easy to calculate in your head, you would have ended up with 0 divided by 1. Well, 0 divided by 1 is okay. 0 divided by 1, well, that's just 0. So my slope here is 0, and that means that I'd have a flat line with no heartbeat, a flat line. If you weren't sure, you totally could toss this particular part of your calculations into Desmos and it would give you the computation of 0. See y'all in class.